hello to all of you. So we are now on our second type of transmission line. So from the last slide, we described from the performance of the line, ABCD constants, the short line approximate, and the process on how ABCD constants was derived. Now in this slide here, we will represent a nominal T method or a medium length line. So this is a medium length or medium lines. Okay, so the first one is a nominal T, and then the next one will be a nominal pi on the next slide. So here we have a nominal T rather. So from the nominal T method, okay, your capacitance is lumped on the midsection, and the series impedance is distributed on the receiving end voltage and on the sending end. Okay, they are distributed by halves. So here we can say that this is your ZL over 2, or your admittance half, also on this section as well on the sending end, and this one is your lump, okay, admittance Y. So you have here, which is approximately equal to your capacitance. Why? Because your admittance is simply equal to 2 pi FC. Any increase, okay, so let us have the arrow sign and the J parameter, which is 1/90. Any increase in the admittance is also has an increase in C. So if you have divide Y by 2, it will be also the same thing with the capacitance. So it is also this one is also an analogy wherein any increase in Y will also have an increase in the capacitance. So let us have the analytical solutions here. Well, I did not discuss here how these formulas for Vs and Is is was derived. So here I will only discuss this formula here and its corresponding relationship to the ABCD constant. So here we have the Vsn here, Vrn, and this 1 plus Zly all over 2 plus IRZL 1 plus Zly all over 4. So please take note here, okay, that we can correlate this one on your ABCD constant. And then you're sending end current, Vrny plus IR times 1 plus Zly all over 2. Okay, for this purpose, we can now say, if you can still recall what we have done on your short line, that this one is your A constant, AVRN, and then this is your B constant here, which is BIR. Then you have your C, and you have your D. Okay, if we correlate these formulas here, if A is equal to D, then hence we have 1 plus ZLY all over 2. And please take note, A and D is unitless. So for this, yes, it is unitless because A and Y can cancel ohms and mho respectively. And then your C here is definitely your Y, and the unit is mhos. So C is equal to Y. And then your B here has ZL 1 plus ZLY all over 4, which is this. This is your B constant. You can correlate this on your ABCD constant matrix on your 2-port, and thus B is equal to ZL 1 plus ZLY all over 4, and the unit is ohms. So from the characteristic of your ABCD constant, A is equal to D, B is equal to ohms, C is equal to mhos, it follows that general guideline. Now, if you want to make sure if this is correct, now you can use the number 4 characteristic of the ABCD constant, which is A and D. If you subtract it from B and C, the result will be equal to 1. So we did here some algebra, so I will you will be the one who will simplify some things here, but again the answer is simply equal to 1. As you can see here, 1 plus ZLY all over 2 squared. So expand this one, and then you subtract B times C, ZL 1 plus ZLY all over 4 times Y. So if we expand this one, we can have this result here below. and some of the parameters will be cancelled, and thus the remaining parameter will be equal to 1, and thus it is okay simply because we have the correct ABCD constant. So the characteristic of the line and the parameters must be, when you have AD minus BC, must be equal to 1. Okay, let us go further on the next slide on nominal pi circuit. Hi, and hello once again. So we are on our next type of transmission line. It must be 2.B from the ABCD constants, and we need to determine the ABCD constant of this line, which is 2.B, which is a type of medium line, which is a nominal pi circuit or nominal pi method. Okay, we just need to recall what is this nominal pi. So here, the ZL, which is composed of R plus JXL, is lump on the midpoint, and your admittance is distributed along your receiving end and your sending end voltages. So you have Y all over 2, Y all over 2. Okay, and then you have here your currents, your voltages, which is represented by Vs, Is, Ir, and Vrn, and you have your voltages here at your capacitance or your capacitors, which is VCN2 and VCN1, which is simply equal as well to your Vrn, since they are connected in parallel. So one characteristic of this line is very important, simply because when you already know your power systems, almost all of the lines, okay, on the analysis is assumed to be a nominal pi, simply because they tend to be a short line, no? So it simplifies our analysis on transmission lines, especially if you're talking about load flow analysis. Now we can recall analytical solutions. Well, we will not discuss thoroughly on how this currents and voltages is derived, but you can use a little bit of your KVL and KCL the same way in how we discussed nominal pi on the last few slides. So VSN is equal to VRN 1 plus ZL Y all over 2 plus IR times ZL. Then your IS VRN times Y 1 plus ZL Y all over 4 plus IR 1 plus ZL Y all over 2. So if we correlate this again in your ABCD constant formula, so this will be your A, this will be your B, this will be your C, and this will be your D. So you already have an idea, no, on those parameters. So if we correlate or compare this on your ABCD constant matrix, the A is equal to D, 1 plus ZL over 2. As you can observe, this is also the same with the nominal T for the A and D. B is equal to ZL and C is equal to Y, 1 plus ZL Y all over 4. So we need to check based on the characteristics of the ABCD constant, no, in terms of unit. So this one is unitless. Okay, yes, simply because ohms and mos will cancel out. B is in ohms. Okay, yes. And the value of this one is in terms of admittance, which is mos, simply because ZL and Y will cancel out. Now, if you want to check if this ABCD constant of a nominal pi is correct, you can go back to this relationship that A and D vector must be, when you subtract it with B and C, the answer will be 1. So we will do the same pattern. You need to square the 1 plus ZLY squared, okay, by expansion, no? And then minus ZLY, and then multiply by 1 plus ZLY all over 4. So it's like x squared plus 2xy plus y squared. So expand this one, it will become like this. And then expand this term. It will cancel out some of the parameters here or the terms here, and the answer will become equal to 1. So hence, our formula here is correct. So again, you need to, if you have your notes or you have your index cards, you can have this again, no, if you use that habit, no, so that you can store it in your memory, this ABCD constant of nominal pi circuit. Okay, we will go to the last topic or last slide for long lines. Please stay tuned.